Hello everyone. In this video we are going to study a bit more about stereochemistry. The first concept that we are going to cover is what do we mean by retention of configuration. So that is essentially retention of spatial arrangement of groups of an asymmetric carbon during a chemical reaction. So as you can see, here we have an asymmetric carbon, which means a carbon atom that has 4 different substituents, and when this undergoes a chemical reaction with Z such that in the final product all it does is Z replaces the X, in that case we can say that there is retention of configuration because the two species have the same relative configuration and can be related as XCABC to YCABC, and you can simply see that here simply the stereochemistry or the configuration around carbon has not changed, as what it does is the Z has simply replaced the X in the final product. So this is an example of what happens in retention of configuration. Now what is the condition under which this takes place? For retention of configuration to take place, it is very important that no bond to the stereo center is broken during a chemical reaction. Let's try to understand this using an example here. Here we have a chemical reaction where 2-methylbutane 1-ol is heated with concentrated HCl. So what happens is that when this particular reaction takes place, the OH gets replaced by Cl. However, you can note that the configuration around the asymmetric carbon atom has not changed in the product with respect to the reactant. Here is an asymmetric carbon because we have 4 different groups attached to it, and we can easily note that no bond to the stereo center or this particular asymmetric carbon atom has been broken during the chemical reaction. Why? Because the bond that is broken is here between C and OH, and a new bond has been formed between carbon and chlorine. However, the rest of the molecule remains intact such that in this particular reaction, retention of configuration takes place. Let's try to understand what do we mean by inversion of configuration. As you can possibly assume, in inversion configuration, there is loss of spatial arrangement of groups of an asymmetric carbon during a chemical reaction. A typical example in which inversion of configuration takes place is SN2 reaction. In SN2 reaction, what happens is that a strong nucleophile attacks an alkyl halide, giving a transition state which is highly unstable because here the carbon has now 5 bonds attached to it and giving a final product as shown here. So if you look at the final product and compare it with the starting reactant, you can easily see that the configuration of the product is inverted with respect to the configuration of the reactant, such that SN2 mechanism is a typical example of inversion of configuration. You can look at that. If it is an umbrella, you can see that the inversion of configuration takes place like flipping an umbrella upside down. Now, what happens in an SN1 mechanism? So, in an SN1 mechanism, we know that in the step 1 is to generate a carbocation, and in step 2, attack of the nucleophile takes place on the carbocation, giving a final substituted product. Important thing to note here is that the carbocation generated is nothing but planar, such that the attack of the nucleophile can take place from either above the plane or below the plane, where products with both inversion of configuration as well as retention of configuration can take place. To understand this, let's take an example here. Here we have an alkyl halide, and as you can see in an SN1 mechanism, the first step is generation of a carbocation, and if you look at the carbocation, that is planar or it lies in the plane, and attack of the nucleophile can take place in 2 ways. So if the nucleophile attacks this carbocation from this side, you get minus butane 2-ol, and if OH minus attacks the carbocation from this side, you get plus butane 2-ol. And again, if you compare the configuration of the product with the reactant, you can easily see that minus butane 2-ol, and if you compare it with reactant, this is an example of retention of configuration, as the configuration has not changed at all with respect to the reactant. However, if you look at plus butane 2-ol, you can see that the configuration of this product is inverted with respect to the reactant molecule, such that here inversion has taken place. To summarize, it is important to note that when reaction takes place with asymmetric carbon atom, there are 3 possibilities. First is retention, second is inversion, and third is racemization, where products with both inversion and retention of configuration takes place at exactly equal amount, or we have equal amount of 50-50% of both products, that is both inverted and has retention of configuration. So, to understand that, here we have an example. When this particular reactant molecule undergoes a reaction with Z such that this particular product is formed, where the relative configuration of both the reactant and the product are same, we can say that this here retention of configuration has taken place. Whereas, if the configuration of product is inverted with respect to the reactant, here we can say that inversion of configuration has taken place. A third situation where we have both A and B in 50-50 ratio, then we can say that reaction leads to racemization. I hope you are very clear on what concepts that we have discussed in this video. First one is retention of configuration, condition under which that takes place, that is no bond to the stereocenter should be broken. Then we learned about the reaction mechanism of SN2 where inversion of configuration takes place, and SN1 where both inversion as well as retention of configuration can take place. Thank you.